Hi guys, here is the question number 6 from miscellaneous of NBHM 2019. The question is as follows. Let k is a natural number and n is the square of k plus 1. We are asked to evaluate the following sum in the closed form expression in terms of k. The sum is basically from 1 to up to n, where n equal to k plus 1 whole square, and sum is taken over the box of root n. Our boxes is the largest integer less than or equal to x. All we know what is boxes. We know that box of integer is box of 1 is 1, box of 1.5 is basically 1, box of minus 0.2 is equal to minus 1, and so on. I hope you all know what is box function. So we now evaluate n equal to 1 to n box of root n, that is n equal to 1 to n up to k plus 1 square box of root n. We take the index j and simply replace it. Okay, now what we do is that we now partition the index in some different parts. Now what we do is that we first partition j, the index up to 1 square to 2 square, and next we take 2 square to 3 square. Here we include 2 square, but here we don't include 3 square, which is included in the next consideration. And here we see what happens. Here we consider number of terms. How many terms is there? It is basically 2 square minus 1 square, and that is 3, right? And here the number of terms is 3 square minus 2 square. If you consider that is 2 square, that means 4, 5, 6, 7, 8, that means 5 terms. And here 4 square minus 3 square, that is 7 terms. And if you continue so on up to our last term is k plus 1 square, so we go up to k plus 1 square. Here number of term is k plus 1 whole square minus k square equal to 2k plus 1. And the value of each term, the value of each of the term which is our under consideration, that is root j, is then, if you see that if k square, or suppose we take it, okay, let us keep it as k square, no problem. If j is in between k plus 1 whole square, here k equal to 1 square is not included, then k will be less than equal to root j less than k plus 1, and then we all know that what is the value of box of root j, that is k. So in each of the cases the value will be, here the value will be k, that is 2k plus 1, then the value is k. Here it is 2k plus 1, that is 2 into 1 plus 1, then the value will be 1. Here the value is 2 into 2 plus 1, so the value is 2, and so on, we get 3, and so on. Now if we sum that, we have, let us keep that sum as value of the sum as a. So we get a is equal to, how many terms are there which have value 1? We have 2k plus 1 terms which have value 1, and we take the summation from, sorry, here k is fixed, so we cannot use the indexes k, so let us keep it as k1. So k1 starts from 1. For 1, that is, there will be 3 terms which has value 1, so 3 into 1. For k equal to 2, there will be 2 into 2 plus 1, that is 5 terms which has value 2. And next for 3, 2 into 3 plus 1, that is 7 terms which have value 3, and so on. We go up to k, that is 2k plus 1 into k. And if we see the summation, we see that one term is left, that is root over of k plus 1 whole square. And this sum is 2 into summation k1 square, k1 goes up to 1 to k, and next one is k1, again k1 goes up to 1 to k, and this is k plus 1. This sum we all know that k into k plus 1 into 2k plus 1, and this is k into k plus 1 by 2, and this is k plus 1. What do we do that? First take the common k into k plus 1 by 6 from here, so we get that 2 into this, that means 4k plus 2, and here we get 3 into 1, that is 3, and k plus 1. And next we take the common of k plus 1 by 6, then what we get, that 4k square plus 5k, and here it will be 6. So it is our required answer. So if you guys like our solutions, please do subscribe to our channel and share among your friends, so it will keep us motivated to upload more and more videos. Thank you.